Okay, so in this video, we're going to do some examples of completing the square. As promised, now that we've got this concept under our belts and understand it on a very deep level and are super comfortable with it, we're going to test it out and do a couple of examples. I've got 5 here that we're going to do because I think any more than that is going to be a little bit redundant and boring. But I've picked them to be, hopefully, cover all the cases that we need. 2 out of the first 4 have a positive a value, and the other 2 have a negative a value. And then the last one we're just going to make up as we go, because I think it's really important to show that this actually works for every quadratic. If you just saw the first 4, you might think, okay, these are kind of cherry-picked to be nice, and they are. So the last one will be messy and not necessarily have, probably not have integer values of h and k. But it's important to see that you actually can do this for any quadratic. So, okay, the first one. We have here y is equal to 2x squared minus 4x plus 5. So our a value is 2, our b value is negative 4. Of course, the c value is 5, although we don't really care about that. We're just interested in the b and the a, because the sneaky 0 term, b squared over 4a, that we're going to be adding and subtracting, is completely determined by the b and the a. So this is negative 4, of course, squared over 4 times 2, which is 16 over 8, which is 2. So we are going to be adding and subtracting 2 from this equation. We're going to be getting this thing equal to 2x squared minus 4x plus 2 plus 5 minus 2. And there, let me fill out that x a little bit more. There is the adding and subtracting. There is the sneaky 0. So this, of course, becomes the 5 minus 2 is going to become plus 3. And this is our perfect square term. This is going to become the square root of 2x squared. And then this is something we didn't mention explicitly in the derivation video, but if you look, it actually is kind of implied there. This is one of the things that throws people off a little bit. It's not going to be plus. In the derivation video, we saw that we were going to end up with square root of a times x plus b over 2 times the square root of a squared plus c minus b squared over 4a at this step. And this included the possibility that b could be negative, right? If b is negative, we're going to be subtracting something there. This trips people up a lot, but it shouldn't. If you think about this, it totally makes sense. So we're subtracting here. This is going to be b over the square root of a times 2. The square root of a is root 2, and 2 is just 2, and b is negative 4. So this is going to be minus 4 over the square root of 2 times 2 squared plus 3. And that, just to really emphasize this, because it's the first time we're doing it, this is the b. This is the plus b, and then underneath there we have the square root of a, which is the square root of a, and then we have the 2, which is just the 2. So this is a complete correspondence with what we did in the concept video. And of course we then get, I'll just do this to be really careful, really step by step. We're going to get root 2 times x minus, and then the 4 will cancel with the 2, and we'll get 2 over root 2 squared plus 3, and 2 over root 2 is of course just root 2, so this becomes root 2x. I'm getting a little bit ahead. Let me do it really carefully and step by step, at least the first time. Root 2x minus root 2, because it cancels with the 2. The root 2 cancels with the root 2 in the bottom, plus 3. And now I can factor out that root 2 and get x minus 1 squared plus 3, which is, of course, root 2 squared times x minus 1 squared plus 3, which is 2x minus 1 squared plus 3. So now if I want to graph this quadratic, it's pretty easy to find. It's pretty easy to find the vertex. Maybe that's what I'll do in orange. The vertex of this quadratic is going to occur at 1 and 3, right? This is the h. The h is 1, and remember in our let me do that in orange as well. In our vertex form of a quadratic, we have y is equal to a x minus h squared plus k. So the k is easy to find. It's just k, but we're not. It's a lot of people make the mistake this is one of the more common ones, of saying that this x coordinate would be -1 because I see a -1 in the brackets with the x. It's actually not that. It's the positive one, right? Because we're subtracting 1. If we had 2 times x plus 1 squared plus 3, then that would be 2 times x minus -1 squared plus 3, and then the h, the x coordinate of the vertex, would be here, -1. And so this is an important subtlety to keep in mind. But because we got x minus 1 squared, we get a vertex at 1 and 3, and so that is the vertex of our parabola, and then we can graph it. Well, I don't know why that got all wavy. There we go. It's slightly better, and that's a little bit better. Of course, to fully graph this thing, we want to also know the roots, but that's what we use factored form for. With completing the square, we're doing it, of course, to find the vertex form. So that takes care of it. We get the vertex. What is this color that I'm using now? We get the vertex at 1, 3. Okay. Second one. Now we have y is equal to 3x squared plus 12x plus 5. I thought I made this one negative. I hope it's the third and fourth one are negative. I'm pretty sure they are. If not, we'll make up a -1. So we get here a is equal to 3, b is equal to 12, and so b squared over 4a is equal to 12 squared over 4 times 3. Since 4 times 3 is 12, this is just going to be 12. So we're going to be adding and subtracting 12 to this, and to and from. So we get 3x squared plus 12x plus 12 plus 5 minus 12. Again, adding and subtracting the b squared over 4a. And this gives us this one. We can do it a couple ways. We could factor out a 3, but it's not necessary here. We can just say that this is going to be, because I'd like to keep it consistent with the exact way we did it in the video, I'm going to say this is root 3 times x plus the square root of 12 squared. That's the perfect square term that we saw in the video. Great practice if you want, though. You can factor out the 3 and do it that way. And then this is going to be minus. I'm subtracting 12 from 5, so I get -7. And then this, again, we'll do it very step by step. This is root 3x plus the square root of 12 is the square root of 3 times 4 squared minus 7, which is going to be square root of 3x plus 2 times the square root of 3. After I square that, I take, because this is root 3 times root 4, of course, using our exponent rules, our radical rules, squared minus 7, and this is, now I factor out the root 3, I get x plus 2 squared minus 7, and then last step, this just becomes 3x plus 2 squared minus 7. So again, I can now graph this thing, because I think it's a nice way to wrap these up by actually seeing what we got out of this. I can see that this thing has its vertex, and I have to, let me move this up a little bit actually, because I'm going to run out of space if I want to make it to scale. This is going to have, let me extend the axes down a bit. This is going to have its vertex at -2 and -7. 1, 2, 3, 4, 5, 6, well, 7. There we go. I made it just low enough. That's -7. So that is the vertex, and the thing goes up. It goes up like this. And again, that's really ugly, but it doesn't matter. And so again, this is just because this is a x minus h squared plus k. So this lets me know that the k is -7, and the h is, this is -2. So the h is going to be -2 there. Okay, next one. Here we go. Okay, finally we've got one with a -a. I knew I put one in here. So here we have a is equal to -1 and b is equal to -6. And so now, because the a is negative, I'm going to stop and factor it out. I'm going to stop and say this is negative x squared plus 6x plus 11. And then I'm going to deal with this one plus 6x plus 11. And then just remember, that's very important to remember to multiply through by the negative again after I've dealt with this. And this again gets us out of factoring, just always factoring out the a from the first two terms, which is what they're always telling you to do in high school, and which just turns everyone's minds inside out and is totally unnecessary. This is much simpler, cleaner way to do it in my opinion, at least. So okay, we have x squared plus 6x plus 11, and now a is equal to 1 and b is equal to 6. So we get b squared over 4a is equal to 36 over 4, which is equal to 9. So I'm going to add and subtract 9 from this. I get x squared plus 6x plus 9 plus 11 minus 9. This is of course going to turn into a 2, and this is x plus 3 squared. So that was nice. That was a nice one because this was a nice perfect square because the a value was a multiple of 1, and it was 1 after we factored out the negative. We're going to get a nice clean perfect square here. We don't have to do any factoring out of roots or anything. And then I add 2 to this, and then last step I have to multiply by negative 1. So I get negative x plus 3 squared plus 2 is going to be negative x plus 3 squared minus 2. And so now I can see that let me do this in again orange, I can see that the vertex is at negative 3, negative 2. And this thing is downward facing. This is a downward facing quadratic. So it's going to be a maximum. That is going to be the maximum value of this thing is negative 3 and negative 2. It's going to look something like this. Terrific. Okay. There we go. And another negative one. I guess I saved them. I thought I'd space these out, but I guess it doesn't matter. Here we go. Negative 2 is equal to a, so I get an a value of negative 2. I don't even know why I'm writing this. We're gonna factor it out. So we're gonna before we do anything else, we're gonna write this as negative 2x squared plus 16x plus 25. And now we're going to work with this, and just remember to multiply by the negative 1 at the end. So we're looking at 2x squared plus 16x plus 25, and now we have an a value of 2 and a b value of 16. So b squared over 4a is going to be 16 squared over 4 times 2. And before I start doing, you might start getting scared because we have to do a 16 squared, which of course is not so hard to do. But we actually don't need to do that here. We can write this in its prime factorization. We can write 16 as 4 squared, or 2 to the power of 2 squared. This will be 4 squared over 4 times 2, and the 4 squared is of course squared. Or I can write this as 4 to the power of 4 over 4 times 2 using my exponent laws, or because 4 is equal to 2 squared, right? 4 is equal to 2 squared. I can write this as 2 squared over 2 squared times 2, which will be 2 to the power of, or sorry, that was 2 squared to the power of 4. There we go. Almost made a really silly mistake, which is 2 to the power of 8 over 2 to the power of 3, which is 2 to the power of 5, which is 32. So just, and I'm not actually sure how much easier that was than just squaring the 16, but this is something that you should know you can do. You can always break things down into prime factors and then do the canceling. But there's another video on that. Just thought I'd throw that in here as an example of when it can save you from doing something scary like squaring 16. Okay, so my sneaky zero term is b squared over 4a. So I'm going to re-express this as 2x squared plus 16x plus 32 plus 25 minus 32. And this, of course, is negative 7. And this bit is going to be the square root of 2 times x plus the square root of 32 squared. And then I'm subtracting the 7. And what is the square root of 32? Well, I'm going to again express 32 in terms of its prime factorization. It is 2 to the 5, and that's a horrible 5, 2 to the 5, which I'm going to write as 2 to the 4 times 2 for the purposes of this. because then I can take the square root of 2 to the 4, right, and get 2 squared. 2 to the 4, if I take the square root, is going to be 2 to the 4. It's going to be 2 to the 4 to the 1 over 2, which is going to be 2 squared. So I can write this as square root of 2 times x plus 2 root 2, 4 root 2 rather, 4 root 2. Let me do this step by step. I don't want to confuse people. Sorry. We'll make this root 2x plus the square root of 2 to the 4 is 8, right? So or 2 to the 4 is 16 rather. So I'm confusing myself here. 16 times 2 squared minus 7, which I can write as, again, being really step by step, root 2x plus root 16 root 2 squared minus 7, which is, again, root 2. I can factor, I'll skip a step because this is getting kind of strange, x plus 4 squared minus 7. And that's just using the fact that square root of 16 is 4. And last but not least, I square the root 2, and I get 2 times x plus 4 squared minus 7. And after all that, I can't forget that I factored out a negative 1 up here. So I have to multiply the whole thing. I have to multiply the whole thing by negative 1 and make this negative 2 x plus 4 squared plus 7. And again, now I'll graph it. And I'll just, because I have like no space here, I won't make this to scale. I'll just make it so that we can see what the point of doing this was. Our vertex is at negative 4 and 7, and that's a max. So I'm just going to call this negative 4 and 7, and then that will be the maximum value. And this is totally not to scale, but I already wrote in the 5 there, so I think this is a bit easier than moving it down, and the scale is not important. Okay, so last but not least, I'm just going to make one up, because these were all cherry picked. I reverse engineered those to be nice and have integer values of h and k, but it's really important to see that we can do this for absolutely anything. So let's say y is equal to negative 7x squared plus 2x minus 9. Just completely, totally made up these random numbers. So we're going to get something messy, but nevertheless, we're going to get something. We're going to get a completed square quadratic, which we can then graph. We can find the vertex. We are going to get the vertex form of this. So again, because the a is negative, the first thing I'm going to do is factor out the negative 1 and make this 7x squared minus 2x plus 9. And then I'm going to work with that instead. 7x squared minus 2x plus 9. So I get an a value of 7 and a b value of negative 2. So I get my b squared over 4a term is negative 2 squared over 4 times 7. Negative 2 squared is 4, so that's going to cancel, and I'm just going to get a 1 over 7. That's my b squared over 4a. This is gross. It's going to be a 1 over 7. And so I'm going to add and subtract 1 over 7 now, and make this 7x squared minus 2x plus 1 over 7 plus 9 minus 1 over 7. And this is, like I said, this is not going to be pretty. Right, I'm going to have to take square root of 7. I'm going to have to do some, common denominator stuff. But it's okay to get fractions. I can absolutely get fractions, and even irrational. And if you're interested in what exactly an irrational number is, we have videos on that. Please do go check it out. But we're going to get something that looks like involving the square root of 7, and people get uncomfortable about this. But the square root of 7 is an honest real number. It is the square root of a natural number, which is not a perfect square, so it's going to be irrational. But we can just leave it like this, right? We don't. In high school, people are always panicking. They don't want to do this. We have to put it into a calculator, get a decimal. But you get out of a calculator is actually a decimal approximation. It's not the exact number. This is the exact number. There's nothing wrong with just writing the square root of 7 or square root of 3 or square root of any number which isn't a perfect square. And that is your answer. So. Because I know a lot of people are going to be watching this getting uncomfortable. This is actually totally kosher. We can absolutely do this. All right. So again, we have this k value, which is 9 minus 1 over 7. I'm going to make a common denominator and express 9 as 63 over 7 minus 1 over 7 here. So we're going to get, this is 62 over 7, which is not a nice number. It's rational, but it's not an integer, but that's life sometimes. And this, what is this going to be? Now we have to stop and think for a second because we don't have perfect squares here. This is going to be, same thing as we did in the concept video, the square root of this, so square root of 7 times x, minus, because we have a negative b, minus the and let me keep the color coding consistent, minus the square root of this. What is the square root of 1 over 7? It's, well, let's do it on the side here. It is the square root of 1 over 7 is the, let me do this really step by step. The square root of 1 over 7 is the square root of 1 over the square root of 7, using our exponent or radical rules, which is 1 over the square root of 7, which, because we generally want to rationalize the denominator, right? We don't want radicals in the denominator. I'm going to multiply this by root 7 over root 7 to get root 7 over 7, which is the standard or canonical way of representing 1 over the root of a non perfect square. So if you have like 1 over root 2 is one which comes up a lot in trig. We usually write this as root 2 over 2. After we multiply the top and bottom, we use a sneaky 1. We've been using sneaky zeros here. We're going to use a sneaky 1 to write this as 1 over root 2 times root 2 over 2, which is just 1, written in a sneaky way, which will be root 2, or that was root 2 over root 2. We're going to end up with root 2 over 2. So we do the same thing, and we're just going to write here, for the square root of 1 over 7, we're going to write root 7 over 7, and this is squared. And then we're adding, we already decided we're adding 62 over 7 here. And then the next step, of course, is always, we're going to factor out the coefficient of the x. We're going to make this root 7 times x, now minus 1 over 7 squared, plus 62 over 7. When we square the square root of 7, we just get 7, x minus 1 over 7 squared, plus 62 over 7. And so again, we really didn't need to panic, and because I know this is something that people almost don't want to accept, but we don't have to panic over the idea that we have a square root of 7 in there. We can just write the square root of 7. That is a real number. The real numbers are complete. Although you don't need to know what that means right now. If you're interested, do go check out the video on that. But we ended up squaring it again at the end anyway, so it actually didn't matter that we had this irrational number. It would have been fine, absolutely fine, to leave an irrational number like root 7 in our answer, as long as it wasn't in the denominator we want to rationalize. But we didn't. It was all for naught. We didn't have to worry about that anyway. We just squared it and wound up with a positive, with a normal 7 anyway. But and why am I making Freudian slips and talking about positives? Because we have to multiply by this negative. I'm remembering that we factored out a negative, and this is really easy to forget. So be careful. Doing it this way makes it a lot easier to understand, makes it simpler, and gets you out of that sort of annoying mind-bendy stuff that comes from factoring out the a from the first two terms that people really stumble over. But you have to remember to put in the negative. Always remember to put the negative back in at the end. And we get negative 7 x minus 1 over 7 squared minus 62 over 7. And this lets us see where the, and I'm not going to try to do this one to scale because it's rational numbers. This lets us see where the, and actually, although I'm going to move this up a little bit, where the vertex of this quadratic is. So the x coordinate is negative 1 over 7 here. Or sorry, it's positive 1 over 7. I'm being really silly. It is positive 1 over 7 because the h value is negative 1 over 7. Or the h value, good God, I've got to wrap this up. I'm getting tired. The h value is 1 over 7, right? This is x minus h. So the h is 1 over 7. And then this is nowhere near close to scale, but way down at the bottom here, we're going to get negative 62 over 7. And these are the coordinates of the vertex. So, and this is upward facing because the a value is negative, it's negative 7, and that's it. That is it. So hopefully you were following along and had an easy time with all of these. And I always say you can never do too many practice problems. But if you've got it, at this point, you've got it. So if you're going to do any more practice on this, again, I would suggest learning to make sure that you know how to derive it for yourself, and that you could explain the formula to somebody else. Because if you noticed, all along we've just been finding the a and the b and computing the b squared over 4a. It's the exact same thing every time, and then just remembering little things like putting a negative in here inside the square term when the b is negative, and factoring out a negative at the beginning if the a is negative, and then multiplying by -1 again at the end. And if you keep those little things in mind, you should never ever screw up a completing the square problem. And like I said, it is something that you need to know how to do.